All right, so today we're diving into something that I think is super helpful for anyone trying to wrap their head around, the whole world of AI.
Oh, absolutely.
We're talking about Clause 9 from that ISO standard, the ISO IEC 229889.2022, the one that lays out all the AI terms and concepts.
Right, right.
And specifically, we're focusing on how it categorizes AI into different fields, basically looking at what AI does. And I think this is really useful because it breaks down this massive field into like these manageable chunks that we can actually get our heads around. So for you, our listener, that means today we're going to be going through each of these fields step by step, kind of like walking through a syllabus, and really getting into the nitty-gritty of what each one is about and where AI is actually being used.
Yeah, it's like having this organized curriculum, right, for understanding all these different areas of expertise within AI.
Exactly, exactly. And our main textbook for this deep dive, like I said, is that ISO standard, the 22989.2022.
Right.
So shall we get started with our first lesson then?
Let's do it.
Okay, so first up we have 9.1, computer vision and image recognition.
Ah, yes.
Now, the standard defines computer vision as, I'm going to quote this directly, the capability of a functional unit to acquire, process, and interpret data representing images or video.
Okay.
So essentially, we're talking about machines being able to like see and understand visual information, kind of like we do.
Right.
And this, of course, is closely tied to image recognition, which is basically, how we work with and process those digital images, whether they're still pictures or videos.
Yeah, and the source of those images, that visual information, can come from a variety of places, right? The standard mentions things like digital image sensors, like what you have in your smartphone camera.
Right.
But it also includes digitally scanned, older analog images, like when you scan an old photograph,
Right, right.
and even other graphical input devices. So it really covers a broad spectrum of how we get that visual data into the digital world.
Yeah, absolutely. And then, of course, there's the question of, well, what does a computer actually see when it looks at a digital image?
Right.
Because it's not seeing a picture in the same way that we do.
Right.
The standard actually describes it as a matrix of numbers that represent different shades of gray or colors,
Right.
or sometimes as a collection of vectors.
Interesting.
And it also points out that these images often have metadata attached to them.
Right.
Which is kind of like, the information you might find on the back of an old photograph, the date it was taken, the location, things like that.
Right.
And then, of course, there's also the practical need for compression
Of course.
to make these files smaller so we can actually store them and share them easily.
Yeah, absolutely. That digital structure, that's the language that, computer vision algorithms actually understand. And that metadata, it's not just like a little side note. It provides it can provide crucial context.
Yeah.
Helping the AI actually make sense of what it's seeing.
Yeah. Yeah, it's really fascinating when you think about it. Something that seems so natural to us, like seeing, is actually this incredibly complex process for a machine where it's interacting with all this numerical data.
Yeah.
So, okay, let's talk about what AI actually does with this visual information. The standard gives us some really cool examples. So one example is identifying specific images within a set. So like, finding all the pictures of dogs in a huge collection of photos.
Right.
Then there's, of course, self-driving vehicles. I mean, this is huge. The AI needs to be able to instantly detect and understand things like traffic lights, pedestrians, other cars.
Yeah.
And then in healthcare, you have AI being used to find diseases and anomalies in medical scans. And in manufacturing, it's used for spotting defects on assembly lines.
Yeah.
Oh, and we can't forget facial recognition.
Oh, of course.
That's a big one.
Yeah. Yeah. These examples really highlight just how diverse computer vision is.
Yeah.
And just consider the complexity involved in something like a self-driving car. It doesn't just see a red light, right?
Yeah.
It have to interpret that as a command to stop, understand the urgency of that command, and then actually execute that action.
Right, right.
And similarly in medical imaging, AI can sometimes pick up on these subtle patterns that even a trained human eye might miss.
Yeah, that's amazing.
It's pretty incredible.
So how does it all work?
Well, the standard actually breaks down the key steps involved in computer vision. So first you have image acquisition, which is just, getting the image.
Right.
Then there might be some pre-processing involved, like resampling and scaling to make sure all the images are a consistent size.
Okay.
And then you have things like noise reduction to clean up the image and contrast enhancement to make the details stand out more.
Right. And then comes the really important part, feature extraction. This is where the AI starts to pick out the important elements in the image.
Yeah.
And then you have segmentation, which is kind of like dividing the image into meaningful regions.
Okay.
And then object detection, where the AI actually locates specific objects in the image.
Right.
And finally, classification, where it identifies what those objects actually are.
Wow. It's a multi-stage process.
It really is. It's not just one thing. And each of these stages involves, its own set of complex algorithms. But the standard does mention that one particularly successful approach in recent years has been the use of what are called deep convolutional neural networks.
CNNs?
Yeah, CNNs. They're a type of deep learning that has shown like really impressive accuracy and efficiency in handling, these complex visual tasks.
Yeah, they're particularly good at learning those patterns within image data.
Exactly. Okay, so we've covered how machines can learn to see. Now let's move on to our next topic. 9.2, natural language processing, or NLP.
Okay.
Now, the standard defines this as, again, I'm quoting directly, the capability of a functional unit to process and interpret natural language. And I think it's really important to understand that when we say natural language, we're talking about the way humans communicate every day.
Right.
So that's through text, speech, even sign language.
Yeah.
And the rules of natural language, that they're constantly evolving based on how we use it, unlike, computer code or formal logic, which have very fixed rules.
Yeah, and that's really where the challenge of NLP lies, right? It's in that that inherent ambiguity and fluidity of how we use language. Words can have multiple meanings.
Right.
We rely heavily on context, and language itself is always changing.
Exactly. And that's what makes NLP so fascinating and so challenging. And it's really a field that sits at the intersection of linguistics, computer science, and, of course, AI.
Yeah, absolutely.
Now, the standard actually breaks down NLP into several key areas, which I think is really helpful for understanding its different facets.
Okay.
So first up, we have NLU, which stands for Natural Language Understanding. And this is all about enabling computers to truly grasp the meaning behind what we're saying or writing.
Right.
And the standard points out some of the challenges here. One of them is polysemy.
Polysemy.
Yeah, which is basically the fact that a single word can have multiple meanings.
Right.
So, think about the word train.
Okay.
It could refer to, a mode of transportation or the act of teaching someone.
Yeah, good example.
So NLU needs to figure out which meaning we actually intend.
Yeah.
And that's where context comes in.
Yeah, it has to look at the surrounding words, the overall situation, to really decipher what we mean.
Exactly.
It's much more than just, looking up words in a dictionary.
Right. It's really about understanding the nuances of language.
Yeah.
Then we have NLG, natural language generation. And this is kind of like the reverse of NLU.
Okay.
It's about taking information or data and turning it into human-readable text or speech.
So it's like AI speaking or writing to us.
Exactly. And the standard even mentions that it's important to make that output sound natural, like a human would actually say or write it.
Right. So that means choosing the right phrasing, the right sentence structure, all those things that, we do naturally, but that are actually quite complex for a machine to replicate.
Yeah, absolutely. And this is really important for things like, chatbots that need to be able to have conversations with us.
Right.
Or systems that automatically generate summaries of long documents.
Right.
They need to be able to communicate in a way that we understand and that feels natural to us.
Yeah, it's all about making that interaction with AI feel more human-like.
Exactly. Okay, next up we have POS tagging.
POS tagging.
Yeah, it stands for part of speech tagging.
Okay.
And this is basically about identifying the grammatical role of each word in a sentence.
So like whether it's a noun, a verb, an adjective, and so on.
Exactly. And you might think, oh, that's pretty straightforward.
Yeah.
But, the standard points out that even this seemingly simple task can be complicated by that polysemy we were talking about earlier.
Right, because a word can function as different parts of speech depending on how it's used.
Exactly. So run can be a verb as in I run every morning.
Right.
But it can also be a noun like I went for a run.
Yeah.
So POS tagging has to figure that out.
Okay. And why is that so important? Why do we need to tag the parts of speech?
Well, because it's a fundamental step for a lot of other NLP tasks. By understanding the grammatical function of each word, the AI can start to analyze the sentence structure, figure out the relationships between the words, and really start to understand the meaning of what's being said.
Okay, so it's like laying the groundwork for deeper analysis.
Exactly, exactly. Okay, next up we have NER, named Entity Recognition.
NER.
Yeah, and this is about identifying and categorizing specific entities that are mentioned in text or speech.
So like names of people, places, organizations, dates, times, that kind of thing.
Exactly. And the standard points out that once these entities are identified, you can often extract even more information about them.
Oh, okay.
So, like, if you identify someone's name, you might also be able to figure out their job title. Or, if you identify an event, you might be able to figure out the location of that event.
Right, right. So it's about picking out those key pieces of information and understanding what they represent.
Exactly, exactly. And this is really crucial for things like information extraction from large amounts of text.
Yeah, like imagine an AI reading a news article.
Right.
NER would help it identify the key players, the places involved, the organizations mentioned, and really create this sort of skeleton of the important facts in the article.
Yeah, absolutely. Okay, next up we have question answering. And the goal here is pretty straightforward. It's to provide relevant answers to questions that are posed in natural language.
So like you ask a question and the AI gives you the answer.
Exactly. And the standard emphasizes that this is different from simple keyword-based search.
Okay.
Because it's not just about finding documents that might contain the keywords in your question.
Right.
It's about actually understanding the question and providing a direct answer.
So it's more like having a conversation with the AI.
Exactly. Exactly. It's about providing a more interactive and informative experience.
Yeah, okay.
Okay, next we have MT, machine translation.
MP.
Yeah, which is basically the automated translation of text or speech from one natural language to another.
Right.
And the standard highlights some of the major challenges here, including, well, you guessed it, polysemy again.
Of course, always collision.
Always polysemy. But also the fact that, context can be interpreted differently across cultures.
Right.
And then there are the grammatical variations between languages. And even the unique challenges posed by writing systems, like those that use logograms, which are basically symbols that represent whole words or concepts.
Right.
So it's not just about substituting words one for one. There's a lot of complexity involved in truly capturing the meaning and nuance of what's being said.
Yeah, it's a really difficult problem, but machine translation has actually come a long way, especially with the rise of neural networks.
Absolutely. And the standard actually mentions the evolution of translation methods from rule-based systems to statistical approaches and now to these neural network-based approaches, which have been really impressive.
Yeah, they've definitely shown a lot of promise. But, truly capturing all those nuances, the idioms, the cultural context, that still remains a big area of research.
Absolutely. Absolutely. Okay, moving on, we have OCR, optical character recognition.
OCR.
Yeah, and this is basically the technology that converts images of typed or handwritten text into machine-readable digital text.
Right, so it's like when you scan a document, and then you can actually edit the text on your computer.
Exactly, exactly. And this is crucial for making, all those physical documents out there accessible to computers for analysis and processing.
Yeah, it's like building a bridge between the physical world and the digital world.
Exactly. Okay, next we have relationship extraction. And this is about identifying and understanding the connections between entities that are mentioned in text.
Okay.
So the standard gives a good example. It's like recognizing that Al Pacino starred in the movie Serpico.
Right.
So you're not just identifying the entities, you're also understanding how they relate to each other.
So it's like building a network of relationships.
Exactly, exactly. And this allows for a much deeper understanding of the information that's being conveyed in the text.
Yeah, it's like going beyond just the individual pieces of information and understanding the bigger picture.
Exactly. Okay, next we have IR, information retrieval.
IR.
Yeah, which is often just called search. And this is all about, finding information that's relevant to a user's needs within a huge collection of data.
So it's what powers our search engines.
Exactly. The system compares the user's query with the content using algorithms to predict relevance.
Right.
And then it presents the most likely results, usually in a ranked list.
Yeah.
And the standard points out that this can handle all sorts of information, not just text.
Right. Right.
So, it's a really powerful tool for navigating the massive amount of digital information that's out there.
Yeah, absolutely.
Okay, next up we have sentiment analysis.
Sentiment analysis.
Yeah,
Okay.
and this is about computationally determining and categorizing the emotional tone that's expressed in text, speech, or even images.
So like whether something is positive, negative, neutral.
Exactly. It's also sometimes called opinion mining,
Okay.
and it's widely used to understand things like customer feedback.
Right. So you can analyze reviews and see how people feel about a product or service.
Exactly, exactly. It's a really powerful tool for understanding public opinion.
Yeah.
Okay, and then we have automatic summarization.
Okay.
And the standard explains that there are two main approaches to this. There's extractive summarization, where the AI basically selects key sentences from the original text and combines them.
Okay.
And then there's abstractive summarization, where the AI actually tries to understand the text and then generate a new concise summary in its own words.
Wow. So it's like the AI is writing its own summary.
Exactly. And it's interesting to note that abstractive summarization is actually closely related to NLG, that natural language generation we talked about earlier.
Right, because it involves generating new text.
Exactly. And this is really useful because it allows us to quickly grasp the main points of long articles or documents without having to read the whole thing.
Yeah, that could be a huge time saver.
Absolutely. And finally, we have dialogue management.
Dialogue management.
Yeah.
Okay.
And this is basically the process of managing a conversation between a user and an AI system in natural language.
So like when you're talking to a chatbot or a virtual assistant.
Exactly. And the standard mentions that this involves using rules and machine learning techniques to create more natural and effective interactions.
Right. So it's not just about responding to keywords. It's about actually having a back and forth conversation.
Exactly. It's about making it feel more like you're interacting with a helpful agent rather than just a machine.
Right. And that's what makes those chatbots and virtual assistants feel so much more sophisticated.
Absolutely. So that was quite a tour through the world of NLP, huh?
It really was.
And as the standard highlights all these different components of NLP, they enable a whole range of applications that we use every day.
Oh, yeah.
I mean, from handwriting and speech recognition to spam filtering, digital assistance, machine translation, text summarization. It's really amazing how integral NLP has become to our interaction with technology.
Yeah, it's a foundational pillar of modern AI. I mean, it allows machines to understand, process, and generate human language, which
Yeah.
unlocks this wealth of information and communication that we have.
Absolutely. Absolutely. Okay, let's move on to our next topic in Clause 9, which is 9.3, data mining.
Okay.
Now, the standard defines data mining as the application of algorithms for the discovery of valid, novel, and useful information from data.
Okay.
And it points out that this field really started to take off in the late 1990s.
Right.
And it was seen as distinct from traditional statistics.
Okay. So what's the difference?
Well, a key difference is that traditional statistics often starts with a specific question,
Right.
and then it looks for enough data to answer that question definitively.
Okay.
Whereas data mining often starts with a bunch of data, and then it explores that data to find interesting patterns and relationships that might not have been initially suspected.
Ah, okay. So it's more exploratory.
Exactly, exactly. It's more about discovery.
Yeah.
Like imagine a retailer analyzing years of sales data to try to identify unexpected buying trends.
Right. Right.
That's data mining.
Yeah, it's about finding those hidden insights, those correlations that can lead to new knowledge or better decision making.
Exactly, exactly. And the standard actually positions data mining as a key step within the larger process of HDD, knowledge discovery and data.
Yeah.
Yeah, it's the algorithmic modeling step.
Right.
And it even mentions the CRISP-DM model, which is a widely used industry standard that outlines all the different stages involved in a data mining project.
Okay.
And it lists some common data mining techniques like decision trees, clustering, and classification, which we've actually encountered in some of the other AI fields we've discussed.
Right. Right. Those are very versatile techniques. They can be applied to all sorts of data.
Exactly. And what makes data mining so powerful is its ability to extract valuable information from these massive data sets.
Yeah, it can reveal connections and patterns that, humans would never be able to see just by looking at the data.
Absolutely. And the standard even gives an example of this in healthcare, where data mining might reveal subtle correlations between seemingly unrelated factors and the likelihood of a particular disease.
Wow, that's really powerful.
It is. And then the standard briefly touches on the impact of big data, which really started to take off in the mid-2000s.
Right.
And this led to the need for even more intensive data processing
Yeah.
and the rise of data science, which is essentially the big data version of KDD.
Okay.
And it's interesting that the standard clarifies that while we often talk about knowledge discovery, what computers actually produce is information.
Right.
They find patterns, they find correlations.
But not necessarily knowledge itself.
Exactly. The interpretation of that information, figuring out what it really means and how to apply it,
Yeah.
that often still requires human understanding and expertise.
Yeah, that's an important point. The human element is still crucial.
Absolutely. Okay, we've reached our final topic in Clause 9, which is 9.4, planning.
Planning.
Yeah.
Right.
And the standard introduces this as a subdiscipline of AI that's really important for a whole range of industries and businesses.
Like what?
Well, it gives examples like risk management, healthcare, robotics, cybersecurity, basically anywhere where you need to make strategic decisions and figure out the best way to achieve a goal.
Okay, so it's about thinking ahead and making plans.
Exactly. Planning is about enabling machines to automatically determine the sequence of actions that are needed to achieve a specific goal.
Okay.
And it also involves optimizing certain performance metrics like efficiency or cost.
Right, so it's not just about finding a way to do something, it's about finding the best way to do it.
Exactly, exactly. And the standard explains this in terms of system states.
System states.
Yeah. So basically, planning helps an AI system move from its current state to a desired goal state by figuring out the right actions to take. And it also mentions that more complex planning problems have to consider various constraints.
Constraint?
Yeah, like limitations on time, available resources, things like that.
Right, because in the real world, there are always limitations.
Exactly. And the standard gives some really interesting examples of how AI planning is being used in the real world.
Like what?
Well, there's logistics and supply chain management.
Okay.
So figuring out the most efficient way to transport goods.
Right.
And then there's robotics, like path planning for a robot to navigate a complex environment.
Okay.
And then there's game playing, like chess or Go, where you need sophisticated planning algorithms to win.
Right.
And it even extends to fields like security, space technology, and telecommunications network management.
Wow, it's really used in a wide range of applications.
It is. It's pretty amazing. And, it's really a fundamental capability for any AI system that needs to operate in a complex environment and achieve specific objectives.
Yes, the intelligence behind a lot of autonomous systems.
Exactly. So as we wrap up our deep dive into Clause 9, I think it's clear that it provides this really valuable framework for understanding all the different ways that AI is being used today.
Yeah, it breaks down this massive field into these manageable pieces that we can actually understand.
Exactly. And we've explored how machines interpret the visual world through computer vision.
Right.
And the intricacies of human language understanding and generation through NLP.
Right.
And how we can uncover hidden patterns in vast data sets through data mining.
Yeah.
And how AI systems can make strategic decisions and achieve goals through planning.
It's really impressive how much grounds we've covered.
It is. And, each of these fields has its own unique set of challenges and techniques.
Right.
And having this framework, even just at a conceptual level, allows you to really appreciate the specific capabilities and limitations of AI in different contexts.
Absolutely. It gives you a clearer lens through which to view all the amazing advancements that are happening in the field. Yeah, and it makes you wonder, as each of these fields continues to evolve so rapidly, will we start to see the boundaries between them blur?
That's a really interesting question.
Yeah, will we see AI systems that seamlessly integrate capabilities from computer vision, NLP, data mining, and planning?
And if so, what kind of incredible applications will that lead to?
It's exciting to think about.
It really is. It's a fascinating prospect.
Absolutely.
Well, thanks for joining us for this deep dive.
It's been a pleasure.
I hope you found it enlightening.
I certainly have.
And until next time, keep exploring the world of AI.
Definitely. There's always something new to discover.